let's talk about lifetimes in Rust. So lifetime is a construct the compiler, or more specifically it's a borrow checker, uses to ensure all borrows are valid. Specifically, a variable's lifetime begins when it's created and ends when it is destroyed. While lifetimes and scopes are often referred to together, they are not the same. So scopes and lifetimes are not the same. So let us walk through this program. Main function, we are declaring a variable I, and here we are borrowing it. And even though lifetimes are specific to borrows, we also have a lifetime for this variable I. I think it's entire dash static, tick static. How do we check? Um, let's give a try. I'll comment all these things, and let us just do the same. I equals 3, and oh, it won't show up. Okay. Um, then let borrow 1 equals ampersand I. We can borrow this because this has lifetime un until end of this main. So, but this borrows lifetime start here and ends in this block. So this braces ensures we are starting a new scope, and lifetime also end on the ampersand 2I. Again we can borrow. Thing is, just want to see, check the lifetime of a variable in Rust. Is there any other method? Okay. Now ampersand x is borrowed here. It's not declared. Okay, we can come back to this basic simple one. So here we are borrowing a second time. That is also fine. And we can even print ln I without any problem because we have a valid I. We are just taking the borrow, but you cannot print borrow 1 here. You cannot find a value in the scope. It is there. It's not there in the scope itself. Um, but but if you apply the same principle, we can define a function fn and add two variables I32 y I32, and what I will do is I will return a reference for I32, and if you just take let a equals x plus y and just return a, this allow, yeah, consider using static lifetime. So yeah, a has only scope here, and and this is a reference we are returning. So we need to specify the lifetime, how long this reference is, how long a is going to live, that we need to specify. Okay, I am just fixing it with dash. Yeah, still it won't work. Cannot return reference to a local variable a. Return a reference to data on by the current function. This is where the lifetime is starting to play. Uh, Now if you think a has scope until this, but you just return the reference, so it is inside the scope, but what Rust is doing is it's doing an extra check on the lifetime, how long a is going to live. A is going to live only till this point, so you cannot return a reference to a because a is going to die here. So you return, and if you call here let a equals add 5 plus 4, do this, yeah, it's this is the problem. Cannot return a reference to a local variable. So that is was the that is where the lifetime is going to play. um, so let's go to move on to next example, how to give explicit annotation for a lifetime. So we have a function add here, and if you want to specify lifetime, I'm going to specify dash a and dash tick a and tick b, and I'm going to specify the lifetime example. Yeah, here I'm not getting the, I'm getting the reference. We don't need to get the value itself, we can get the reference, and I'm saying let's pass references, but the lifetime of a is, lifetime of x is tick a and lifetime of y is tick b, and I will return a, return a if is not addition. Just thinking, for example, okay. So this case, yeah, this case we just added um, a return type ampersand tick a I32, and we are returning whatever parameter, the first parameter we received, which is a mutable reference to a I32. So the tick a is the lifetime of return parameter is x, since we need to have the same lifetime for that as same as the parameters, so we are giving the same tick a. So if you give tick b, you'll see what will happen. It is throwing an error. Lifetime may not live long enough. Consider adding the following bound. So what that means is uh, tick b might not live, or tick a might not live as long as tick b. So we need to have the tick b longer, right? More than uh, tick a, because x would die here. Then even though y is longer, then uh, we are losing this x. So we are making sure that tick a should be greater than uh, tick b. So for that, I hope we can give a where clause. Let's see. Uh, tick a, tick b. Did it work? Yes, it's working. Uh, so we are giving a time bound here. We are making sure tick a is going to outlive tick b. So we have this return variable longer than or same life as our x parameter. So that is enough for us to make sure that these two pointers references are valid. Okay. Mm, that is one concept. Let's move on to explicit notations. So this example, we are giving two lifetimes. First parameter having tick A as a lifetime. Second reference has the tick B as lifetime. And we're not returning anything here. Function which take no arguments but has a lifetime parameter. So we are stating this function has a lifetime tick A, and the tick A we can use here, but x won't live more than, we are not sure how long tick A is, so you cannot reference x, because x is inside this function, to a variable, right? Attempting to use the lifetime decay as an explicit type annotation inside the function will fall, because lifetime of ampersand underscore x is shorter than that of y. A shorter lifetime cannot be caused into a longer one. Yeah, x is shorter, y is longer, so we cannot, y is decay, so we cannot, decay is longer, so we cannot coerce shorter one to longer one. Solve for this one. And this example, print 1 decay, the function has a decay, and that is same as the parameter reference decay is the lifetime. And yeah, this is we are printing, this should be okay. Yeah, mutable references are possible with lifetime as well. So ampersand decay mute I32, and we can mutate it, the variable. Yeah, that we have seen. And print multi decay and tick b, two references, this also we have seen. Returning references that must have been passed in is acceptable. However, the correct lifetime must be returned. So if you have two parameters tick and tick b, and we are returning x, then the lifetime of the return variable should be tick a. Yeah, I think that's all in this one. Methods also can be annotated similar to functions. So we have a struct here with owner and a single parameter variable I32, and we are implementing the owner, and this is a method because we are getting the self, and the function has a decay, and we are saying the lifetime of this reference is decay, and we are just mutating self. Here another one, it's a reference, not a mutable reference, it's a decay, we can still print self dot zero. The lifetimes are same. Yeah. Annotation of lifetimes in structure are also similar to function. So borrowed decay I32, good, and we have a name to borrow here, borrowed here, another struct, and it has a lifetime type as decay, and both the references has decay as, both the fields x and y has decay as the lifetime, same lifetime as the structure. And same way we can do the same thing for enum. We have to give it in this greater than, less than, inside that we have to give the lifetime, same as we give the generic type. And here a reference, another type, inside variable has a is a reference and has a decay lifetime, same as the enum. And same way we can give traits with lifetime. So if you have a structure, this scenario we have seen, and if you want to implement a default trait for this type, so we have to give the full type, and we also need to give the impl with the lifetime here. Then you can use the implement default. Bounds is what we have seen earlier. Just like generic types can be bounded. uh, for example, if t implements debug trait, something like that, lifetime can also use bounds. The colon character has a slightly different meaning here, but plus is the same. So what that means is t colon tk means all references of t must outlive tk. That's the meaning of this. So we have used this here, right? Oh, this is a lifetime be given. We just mention all the tick b should tick a should outlive uh, tick b. That's the meaning of this. Tick a should be greater than tick b, greater than or equal to, I believe. And similar way, if you give t colon tk, that means all references of t should must outlive tick a lifetime. And if you want to give t colon a trait plus tk, that means type t must implement trait. Obviously, that's the meaning of trait, adding trait here. And all references of t must outlive tk. Yeah, yeah. This is an example. Uh, we have a trait, debug trait. We are deriving debug here on the reference type where where this part, this is the parameter v is a generic parameter with a reference with lifetime tk on t. Since we use tk, we have to specify tk here, and in this case we are giving a bound that all references of t must outlive tk. So that's the meaning of this. So the inner value of the struct must inner references to the inner value, any references to the inner value must outlive tk. Yeah, so you cannot reference. So if you have something like this definition, you cannot have something some inner value is uh, which is died before the struct get destroyed. So we are making sure with this lifetime that we can specify only the inner value, references to the inner values, references as inner values if the reference lifetime outlive decay. Yeah, that's the meaning of that. So it's, you can use ref as a wrapper kind of a reference, wrapper type for a reference. Yeah, and here printf decay. Yeah, this is a function which is taking the parameter, generic parameter, and we are giving t must implement debug because we are using println with colon question mark, and also if any reference comes through this, we want to make sure that t is any references to the t type must outlive decay. Yeah, so that means someone pass some reference here and he cannot destroy that value before this function gets finished. Yeah. Uh, Cohesion. A longer lifetime can be coerced into a shorter one so that it works inside a scope it normally wouldn't work in. This comes in the form of inferred coercion by the Rust compiler and also in the form of declaring a lifetime difference. Okay, let's see this example. A multiply function with decay. First parameter reference has a tick a lifetime, second also has tick a, and if you multiply you don't need to specify the lifetime because it is coerced. It is taken automatically as decay. And if you have this example, choose first. So you have a tick a bound. Tick. What is the meaning of this? This is a bound. So what this means is tick a should outlive tick b. And first parameter is tick a, second parameter is tick b. So from this bound we know that tick b is greater or equal. So we can very well pass first and give tick b as the lifetime for the return type because we know that tick b is going to be greater. No, tick a must outlive tick b. So tick a is greater. So that's the here we take in tick a I32 and return a tick b as a result of coercion. Any references to tick b is greater. Let's try this. Let's try this. A fn first, and we are giving tick a colon tick b comma tick b, and the parameter first. What is the function name? Choose first. Okay, choose first, and first parameter is first with ampersand tick a I32 comma second with ampersand tick b I32, and we are giving tick b I32 as ampersand as the return type. We are returning first. Oh, it's working. So tick any references to tick a must outlive. We are giving tick b as a reference. Choose first. Choose first. Ampersand 5 comma ampersand 6. Yeah, it's actually coercing. Uh, Reads tick a bound tick b comma tick b means reads as lifetime tick a is at least as long as tick b. Tick a is at least as long as tick b. Oh, Here we take in ampersand tk32 and return as the result of conversion. Tk is at least as long as oh, uh, it doesn't matter. Tick A is greater, so we know that even if we give tick B, it doesn't matter, it will go through. Hmm. If you give tick A, it's the lifetime of first itself, even though, yeah, if we are not giving bound, what we'll see what happens. Then it will should throw the error. Yeah, then it will throw the error. Lifetime may not live long enough. So yeah, B is might not, A might not live as long as B. So yeah, we need to give a bound tick B, so we can guarantee that uh, the first will be living because B is the shorter one. Not shorter, at, a- at least as long as tick A is at least as long as tick B. Yeah, that's the meaning. I think this is covered. Yeah, static. Rust has a few reserved lifetime names. One of those is tick static. You might encounter it in two situations. One is when you declare a static variable like this, let s colon, you need to specify the lifetime here with the type, I believe. So I32 ampersand I32 ampersand I32 equals even hello. Oh, okay, let's give str string hello. Oh, let won't work. Let s, yeah, let cannot be used here. Yeah, this is one example. So we defined a static um, variable, static lifetime variable. Another type is tick static as part of trait bound. So when you are defining a uh, function and you want the type to be uh, tick static, so you can use var t colon tick static. Both are related but subtly different and is common source for confusion when learning Rust. So yeah, this is one of the example. This is what I thought of showing. Copy. This is a static variable. We define num as I32 and it will have a lifetime of tick static. As a reference, lifetime tick static indicates that data pointed to or by the reference lives for the entire lifetime of the running program. It can still be coerced into a shorter lifetime. There are two ways to make a variable with tick static lifetime. Both are stored in the read-only memory of the binary. make a constant with static declaration. That is what we have seen here, and this also we have seen, for example, this one, this statement with the ampersand tick static str. Both cases the value will be stored in memory of the binary, and it will be available. Lifetime would be the entire lifetime of the running program, and it can be coerced to a shorter lifetime, but static, this thing, I think we cannot mutate. Let's try whether we can mutate num. um, Num equals 19. Not possible. Mutable. Oh, is it only mutable? Let's give mute. Let's give mute. Use of mutable static is unsafe. Yeah, we cannot use it in the safe first. We have to declare it as a unsafe, I believe. When we do this unsafe, if we want to really mutate the static variables, it work? Yeah, this time unsafe. Oh, okay. You don't need to. You don't need braces here. Just still unsafe. Save fn function. Ah, keep like this. Okay, I'm deleting this. Let's see. Oh, here unsafe. Yeah. So now we don't need unsafe time being. So let's remove this. So this is actually not. We should not declare mutable static variables. It is unsafe. So it's one way of giving lifetime of tick static. Another way is this way declaring the variables, and another way is if you have a parameter, then we can when rate found any variable, we can pass, and it should return. It's not returning anything. Only thing is we want to make sure that verti tick static. Want to leave this tick static. Why it's not compiling? Cannot find D. Yeah, D is t is here, we should declare t. T should, oh, t, we are not using t anywhere. Yeah, this way you can bound t with the tick static. That's what we are discussing here. Trait bound is, yeah, similar thing, any parameter. If you want to, yeah, if you want to do uh, debug plus lifetime bound, you can do similar way. Oh, it import this, I think so. Consider importing. Why there is no quick fix? Use std fmt debug. Yep. So this way you can use straight bound plus lifetime bound. Is I is owned and contain no reference, so it's a tick static. Yeah. If I is just an owned value, then it should be lifetime of tick static. It will be available throughout this main. So you can pass this. This bound is valid. But if you pass a reference, ampersand I only has a lifetime defined by the scope of main. Yeah, even though main is, you cannot think main function's lifetime as the lifetime of this program. In this case, I think it's there, but our compiler won't take that way. So ampersand I only has the lifetime defined by the scope of main, so it's not tick static. So if we pass ampersand I, compiler is not sure that I will be outlive the entire program. And their program, this function also there, right? So any references passing is not allowed if the lifetime is tick static. Mostly owned values will have the tick static. Or yeah, we can give a try with this. Let's pass num on this, right? Num is a static variable. Trait bound num should work. Yeah, it's working. See, it's working. Even though it has a tick static, lifetime of num is tick static, so it's working. And if you want to pass, yes, it will work. It should work because it has tick static. Yes, that is also working. But if you pass, if you just define I equal to 10 and just pass ampersand I, this won't work. Yeah, this won't work. I dropped here while still borrowed. Okay, that is, I don't like that. Want to give z, z, here z, this also should fail. Yeah, failing, and C does not live long enough. Borrowed value does not live long enough. C dropped here while it is borrowed. Argument requires that Z is borrowed for tick static. So if you have some functions and you want to make sure that before calling those functions, the parameter should live throughout the program, then you can just give a lifetime bound. Good feature, right? Yeah, that's what lifetimes. Elision, I think okay, let's discuss elision too. That is the last one. Some lifetime patterns are overwhelmingly common, and so the borrow checker will allow you to omit them to save typing and to improve readability. This is known as elision. Elision exists in Rust solely because these patterns are common. So if you have a lifetime a function with parameter x and it's a reference to i32, you don't need to give the lifetime. Elided input or annotated input essentially has identical signature because lifetime of elided input is inferred by the compiler. Yeah, compiler will take this lifetime, and if you pass, yeah, and if you explicitly give decay, then uh, then if you call elided input ampersand x, the lifetime will be taken for this implicitly, and annotated input ampersand x, the lifetime will be decay implicitly taken, even though we have explicitly given, and elided pass is live elision book. The reason is this function compiles without lifetime annotation is historical. In early versions of Rust, this code wouldn't have compiled because every reference needed an explicit lifetime. At that time, the function signature would have been written like this: tk ampersand tick str and tick str, like this. Now we don't need to give like this. It automatically taken with this signature. And this case tk, you just need to give this parameter lifetime. This will be auto taken. The compiler applies the first rule, which simplifies that each parameter gets its own lifetime. We will call it tick as usual. So now the signature is like this. Where is the rules? Any rules they have written anywhere? Second rule, first rule, or a checker. I think they have written somewhere. lifetimes on functions or method parameters are called input lifetimes, and lifetimes on return values are called output lifetimes. Okay, clear. Compiler uses three rules to figure out lifetimes of references when there are in explicit annotations. The first rule applies to input lifetimes, and second and third rules apply to output lifetimes. The compiler gets to the end of three rules and there are still references for which it cannot figure out lifetimes, compiler will stop with an error. These rules apply to FN definitions as well as impl blocks. The first rule is that compiler assigns a lifetime parameter to each parameter that's a reference. In other words, a function with one parameter gets a lifetime parameter fntk tki32. A function with two parameter gets two separate lifetime parameters, and so on. Yeah, it will automatically get tk implicitly taken. We don't need to specify. Second rule is that if there is exactly one input lifetime parameter, okay, there is only one lifetime parameter, that lifetime is assigned to all output life parameter. It will be default assigned to this output reference. You don't need to specify this tk anymore. If you specify this here and here, then you don't need to specify this. It will be auto taken. Let's try that. Do we have anything with single parameter? No. Okay. Let's build a function single param and x ampersand tk I32, and I'm not giving the lifetime parameter lifetime for this output return type. So it's just ampersand I32, and what will I return? I return 3 ampersand 3. Did it work? Tk is not declared. That's true, because if you are giving any lifetime, you have to give the lifetime like this, same as generic parameter. Yeah, so this is compiling and this lifetime is auto taken as tk. And third rule is that if there are multiple input lifetime parameters, but one of them is ampersand self or ampersand mute self, because this is a method, the lifetime of self is assigned to all output lifetime parameters. Okay, so where is that example? Oh, it's not given. If there are multiple input parameters, so I just define a struct car simple and impl car fn new and percent I32. What is saying? Okay, you don't need to complicate, so just give that, and we are giving self. No, not new. Yeah, just give this new, just return self, as simple as that. Self and car. That's all. and we are defining a method drive and ampersand self. Then what they're saying, the output lifetime. Yeah, I'm giving ampersand str here, and self dot 0, and 0 is ampersand str. Yeah, I have to give, definitely I have to give it decay. Let's give decays. This is a string. I don't know that's a convention or not, but decay is consider introducing it. Okay, of course I can introduce it. Introduced, so it's working, but it's not defined here. It's not defined for the impulse, so I have to give here as well. And missing okay, missing this. What should I give? Yeah, I can give. Yes, get confused. Ampersand str, and let's give s. Yeah, and now problem starting. Car is a tuple struct. Really? Yeah, tuple struct. And you need to give s here like this, but explicit lifetime required in the type of s. Okay, I can give guess lifetime. What happened? C is stopped. What? How C will be impacted by this? Uh, uh, what's going on? Let's compile this. Clear. Cargo check. Borrowed value does not live long enough. How come? I never touched that. Z. Oh, here is. Okay. Oh, okay. But here, I don't understand. How come Z is impacted? Hmm. That's not fair. Z does not live long enough. Z was I32. Is it a bug? Z is dropped while it is borrowed. Funny. Yeah. This is trade bound, right? Static, right? Yeah, yeah. Oh, yeah. This is true. This is true. This is the example we tried. Yeah, this is true. Um, and so car is compiling. So what is third rule we saw? Third rule, second, agree. Where is third one? Third rule is that if there are multiple input lifetime parameters, but one of them is ampersand self or ampersand mute self, Because of this method, the lifetime of self is assigned to all output lifetime. Oh, okay. This is implicitly taken as tick s. I may complicate this. I want to give it as decay, and this is decay. No, yeah, it's still compiling. How come? And I'm not giving the where is the ampersand mu? I'm not giving the lifetime. I don't want to give the lifetime. Yeah. Now it's explicitly tick s is required. Yeah, s should leave tick s, right? Oh, it's uh, where it's a and here it's s and it's and if I give tick yeah, yeah, that should work. That should work. And here also I'm just giving an s with some str with a tick. Yeah, and here tick a. My lifetime tick a shadows lifetime name that is already in scope. Tick. Oh, okay, tick b and tick b. Yeah, this will work, but this thing will have the lifetime of self. That's what they are saying. If I give tick p, throw error, it's throwing error. Tick a, yeah, bound should be there. Otherwise, it's implicitly taking self's lifetime. Okay, I think we have covered most of the topics related to lifetime. Thank you for watching this video. We will see the next one. Thank you.